Hey, what's going on, folks? It's Mike here, and welcome back to the Deep Programming Language series. In this lesson, we're going to continue and revisit a topic that we've talked about previously, Variadic templates. But this time we want to start talking about some of the things that we've learned since learning that topic with mixins and how to make this just a little bit more of a powerful feature and have a little bit of a teaser of what enables this actual feature with the alias sequence, which we'll talk about in the next video. So stay subscribed for that. And otherwise, let's go ahead and dive in on our favorite programming language website here for us deprogrammers on dlang.org. We're going to go to the documentation, the language reference here, and I'm going to go ahead and take us down to templates here and give us a little bit of a refresher here for our template parameters looking on this right side here. And let's go ahead and find here, I'm going to go ahead and just minimize this here, Variadic templates or Variadic function templates. Now in this video, I'm also going to show you some things that we can do with struct and mixins to otherwise make them just a little bit more interesting. So anyways, the idea here is that with a Variadic function template, which we looked at in a previous episode, I believe it was episode number 88, we basically found out that you can have variable number of arguments in your template here by just using the ... parameter. Languages, many other languages have this sort of idea here, and basically it's a way to instantiate a new type or a new function with a variable number of arguments here. And we're going to see that when we have templates, this is one of the things that plays well with mixins. In fact, anything that is templated you can work with in mixins and sort of vice versa because you're generating code with both of those tools. So anyways, let's just go ahead and hold on to this idea here and start with a little bit of a recap of where we left off in a previous video here with the idea of Variadic templates. And if you haven't seen these Variadic template arguments before, I'm going to go ahead and import, actually I think I'll just need standard IO for this one. Let's just go ahead and start there. But anyways, what we did in that video was we wrote a little print function or something similar to this in the template parameter list first here, but this time just saying variable number of template parameters here with ... Now, of course, I can add or enforce a number of them. Like if I want some other type here that must be filled out, then you have at least one value in your variable template argument list there. But otherwise, I'm just going to leave it as is so that I could just print things out. And I believe I did something like this in the previous video here. Let's just go ahead and play around with this a little bit here, where we could just write out args, and then let's just go ahead and call print for this function. And I'm just going to supply some values here, a variable number of them. And let's go ahead and run this program. And you can see that we get our args 1, 2, 3, 4, 5, 6 here written out here. Now, if we want to make this a little bit more interesting here so that they're not just writing out here, we probably want to do something like this here with a for each loop here, and just say for each of our arguments here, let's just write out the args and t. Something of that nature will do the trick there, and then we can see how they are individually treated here. And let's play around with this where we actually specify more explicitly the arguments. So for instance here, let's go ahead and just shorten this just a little bit here. Let's just make this 1, 2, 3, for instance. I'm going to go ahead and give this a run here. What if I put in here int here? So I specify those arguments. Well, it works just the same here. But again, remember that the decompiler is smart enough to figure out in some of these instances what the actual argument types are. Okay, so we have a separate instantiation of the print function that handles 3 integers. And if I were to write another function here that took in, say, a 4th integer, I get yet a 4th version of this function set up here. Okay, so now we can see 1, 2, 3, 4 for the second one and 1, 2, 3 for the first one. Now we also looked at this in the previous lesson here, where if I copy this function here, and if I do a static for each here, and I'm just going to prefix this with static print here. Let's just give it a different name here. And let's just go ahead and look at the fields here, or the args, I'll call them. Let's just leave it as t here. Then we're basically able to, with very little effort, look at the individual fields here. Now let's actually just iterate through each of our template parameters here. So 1, 2, 3, 4 here. And let's go ahead and just make this the index. And I'll go ahead and separate this with another colon here. And the actual type here. Let's go ahead and see if we can get that working here with our static print here. And let's go ahead and try it with 1, 2, 3 here. Something of that nature. Let's go ahead and write that. Now, interestingly, I am getting a few different errors here. It's saying, hey, we're having trouble instantiating this. So let's try that same trick here where we, again, basically try to instantiate the type here. Now, of course, if I'm doing things statically and I'm trying to write out values, that's not really going to play very well here. I mean, it's still going to try to work here. What I really want to do here is just use the pragma, which we learned about here. And what I want to actually do is just write out a message here, and then I can actually write out a variable number of a string here effectively. Let's see if that helped us here. That seemed to have helped us here. Now, you're going to see with RDMD, again, you get this weird behavior because it's compiling twice effectively at compile time, right? The file, and then it's linking it in a separate step in building. So let's just actually run this with DMD. And I'm just going to output this as the program here so that we just see that compilation step here. So from our args here, and I'm going to call this the static print args here. Okay, so there we go here with our 3 integers being printed out. So let's see if we can extend this idea here if I build a struct, for instance. And I just call it some, let's just call it fields for now, I think is reasonable. And do the same idea where I want to pass in basically for the template for this struct a variable number of fields of some sort, okay? So the question is, when I'm doing this, how do I set up the fields? Because I have to sort of know at compile time what the structure of this struct is going to be, how it's laid out in memory. Is it, an int, and a float, for 3 fields or whatever it might be here. So let's go ahead and effectively take this print function here. I'm going to say print fields here. And we could do the same thing here. Let's just go ahead and say, actually, I could probably just copy and paste this code here. Let's go ahead and try that. That's always worth trying. Dangerous to do. But let's see if this just builds here, first and foremost. Okay, so it's still building, which is good here. And how would we instantiate this struct here with our fields? Well, probably what I want to do is something similar here. And I'm just going to use auto here to make my life easier. Let's just call this example. I'll have fields here. Let's say an int, an int, an int, and an int. Or actually, let's make it an int, a float, and a double, just so it's a little bit more distinct. And I'll have 3, 7.2 with an F, and 88.8 or something like that. Okay, let's just kind of see if we're still compiling. And what's it saying here? Initializer provided for struct fields with no fields. Okay, interesting here. Because again, I've templated this struct, but what am I actually doing with those? Right? In the function, it was pretty clear what I'm doing. I'm effectively copying and pasting those. Those become temporary variables that are passed as parameters here. But my struct layout, what am I initializing this struct with, right? If we go way back to our lessons on struct initializers, remember that a struct has the ability to sort of initialize these fields. That's what it's expecting here. It's giving us this constructor here. I mean, what if I give this struct here some constructor here? I'm just going to call it test here, and maybe we'll just write out test so it does something. Does that satisfy it? No, it's still not quite happy here, because again, it's getting confused. It's saying, well, we're expecting one argument for our constructor, right? So as I'm trying to initialize this struct here with a variable number of template arguments, it's saying, well, what can we do with that here? So this is where we can do something useful here with the mixins. And how exactly do I mix this in? Well, I can again use this same idea here, this static for each loop. So let's go ahead and do the static for each. And what we're going to do here is the static, again, I'll grab the index, the field name, and then again for the types, and I'm just going to mix in something here. So some valid decode. What I want to actually mix in is the field. That's going to be the type here. I'll put in a space, And let's just go ahead and call this whatever the field, or we could come up with like a name of the type here. Let's actually just name it field, and then maybe the index after is something reasonable to append to it. I'll just do IDX string of. I think that'll work here. And then again, this needs to be valid decode, so I'm going to put a semicolon here. Let's see if I did that correctly here. Oh, not quite here, because we still have that error with it's expecting a constructor here. If I get rid of this, I can just take advantage of the string literal version of this. And now I can actually compile this here, which is pretty cool here. And it's just going to mix in the fields of my actual struct here, which is super, super neat here. So if I just write out in comments what we've done with this example struct here, is we basically at compile time define something that's just going to generate something called int field, and then the index starting with 0. And then it's going to, again, create something with a float and a double, and then we're just appending, because we want unique names here for each of the fields, something like this here. Okay, so this is something kind of interesting that you can do at compile time with Variadic templates for structs as well, but also combining the idea of a mixin here. So again, where is this kind of stuff useful? Well, again, if we're trying to generate code, or maybe you're parsing in some specification, and you want to be able to generate different types of structures. I mean, you could imagine, for instance, if you're sending network data back and forth, this is kind of the idea that you have. You can create variable, types of structs, which is kind of neat at compile time to set up the different fields here. And what we're going to learn about next video is the idea of an alias sequence and an alias sequence of. So you could actually do interesting things like sort these fields by the largest data type to the smallest data type, so you could always tightly pack up this data if that's something that you want to do here. If you know about, again, struct alignment, you can check out the videos in this playlist on structs and so on. But again, just some interesting ideas of some things that you can do using mixins, and now this idea of Variadic templates with structs now that you can actually generate at compile time. So again, we're getting a new struct every time here that we're instantiating. And if we think that we might want to use this more often here, let's just do one more thing here to kind of put this together. Let's just go ahead and let's grab this line here. And I'm just going to go ahead and create an alias for this. And I'm just going to call this triple here, because we've got 3 fields. And then let's go ahead and compile this. Let's see. Basic type error expected at line 30. Okay, so we got to do a little bit of work here. Again, just remember that an alias is effectively like a replacement here for a text. So again, we're not instantiating the type here. And then we're going to chop off this little part here and just call this a triple or whatever, which is going to create this struct with the fields that we want here. And this should compile and run here. Now let's actually run this code here so we can see what the rest of it does. Again, this is just the stuff that's happening at compile time. And then we can actually run it, and now our print function, that's not the static print, is actually going to print out some things. Let's actually also do one little thing here. Let's just do a write line of our example of that triple. Oops, got to rebuild it, rerun it here. And now we can actually see those fields populated as mentioned here for our struct here. So again, lots of different interesting things you could do. And again, as a challenge, you could try to take these parameters that you pass, you could actually sort them at compile time based off of their size or something, so that you could try to get some sort of optimal alignment. So anyways, folks, with that said, I hope you enjoyed that lesson here. As always, you can follow along all the lessons here on courses.msha.io if you're enjoying the deprogramming language series, and especially some of this metaprogramming stuff. And again, I'll be curious to see what sort of examples that you folks have come up with for using things like mixins, Variadic templates, and just nice use cases where it's actually helping your program, removing complexity. I think there are some really cool use cases that I've had some discussions with some of you folks already on serialization, writing data, building structures based off of specifications, and then sometimes sort of optimizing them in interesting ways, as mentioned in this video, based off of the size and sorting them and so on. So anyways, we'll get more into this stuff as we continue. I'll look forward to your discussions below. And as always, thank you for your time and attention.